then I spent about 5 years at different startups, from my own to early to late stage. And during that time, I worked on iOS and Android primarily. Although I guess at a startup, you do a little bit of everything.
Yeah.
I have your resume on file, but I'd love to learn like a little bit about you and maybe like a project that you worked on.
Yep, for sure.
Thank you for describing those things.
Yeah, for sure.
And then I think in the notes from the recruiter, it says this is a coding round. So I'll just write like a coding question. I'd be curious to like just maybe get your first impressions about the questions. Like you can ask any questions you might have, and then during this process, I'm more curious about like your thought process.
Okay.
And then right now the default is in Java. Do you want to Python? Do you want to change it?
I typically, day to day, I write in Java, but for coding exercise, I typically do Python because it just saves time.
Okay, that sounds good. So for this question, let's say that we get a 2D grid as input.
Okay.
And then let's say that it's an integer grid. And then so maybe there's going to be some values. Let's say that there's going to be zeros and ones.
Okay.
Then let's say that the zero, we want to find the distance for each coordinate to the closest zero. So for instance, like if a tile is already a zero, the distance, if the tile is already a zero, the distance to the closest zero would be zero.
Okay.
So for this one, it's zero. For this one, the closest zero is either to the left or to the right, so the distance is 1. For this tile over here, the closest zero is like 2 units to the left. And so maybe we can label it at 2. Does that make sense so far?
Somewhat.
Okay.
There's 2, this is 0 is 1. But could you, just so I can always refer back to it, you said, could you write down how do you update depending on the number of zeros or what's closest?
Yeah. So for like a coordinate, like maybe like for this coordinate right here, like if we were to just try and find the closest zero, like the distance to the closest zero, we would have to traverse left once and then left once again. For this, like for this in row 2, end of row 2, we have to traverse 2 units in this like grid to get to a 0. So the closest 0 is a distance of 2 away.
Okay.
And then for this one, the closest 0 is, let's say that we could only traverse up, down, left, and right. If we were searching for like a 0 from here, I can go left, left, up, or up, left, left. But this is a distance of 3 units away. Left, left, up, and up, left, left.
Okay. So essentially, because you're trying to find the closest of the nearest, you just run a BFS at each one and find the closest 0.
Okay. Yeah, I think that could work.
Are there any constraints I should know about? Is it always the input a 0 or a 1?
Okay. Yeah, I think let's say that it'll always be a 0 or 1.
Okay.
What other potential constraints can you think of?
Are the edges of the board the end? Like, can I go across the board, or can I assume that's the end? You can't go across.
Let's assume that it's once you get to an edge, that's the end.
Okay. So, and of course, if it's a 1, you find the nearest 0 with the BFS. Is there guaranteed to be at least one in the input?
Let's say if there weren't any ones, what do you think? What could we return, or what could we do?
Well, you just return the input itself unchanged.
Okay, we could do that.
Yeah. And you said the directions we can go up, down, left, or right. There's no limitation, no diagonal. Okay. Yeah, those are the main things that come to mind right now. I can't think of anything else to ask right now. Something else might pop up soon, though.
Okay. Yeah, I think that's fine.
Okay. So let me write down my approach. So, is there any requirements on the space complexity? Do I have to modify the input in place, or do I return a new grid?
Let's say you can just return a new one.
Okay. So let's say iterate through inputs. Element is 0. I think 0 and 3 separate grid and size and inputs. and 0 and 0, 0 separate grid, else if element is 1, and if that's from that element counter, track any till nearest 0. Right, so I'll go forward with that. French reverse. Am I free to check any documentation?
Yeah, that's fine.
I assume though in Python it's to do it. Don't I do it? No, I don't need to copy anything.
Oh, if you don't know the documentation, you can just write like a pseudo API that's named properly.
Yeah, I'll just do it this way for now. List. Let's leave it into this for now. 0, so 4. Range. And I assume the grid will have at least one row and column inside of it. Okay.
We could skip like the verification.
Okay. All right, one thing that's coming out to me, potential optimization is to use a visited set, so you don't keep. If you like, let's say you're at one point here and you go on to one point there, you can sort of save time if you know where the nearest 0 is, for if you're at a later one. But I don't want to write any code for that in case there's weird edge cases where maybe there's a new 0 that's unseen that's brought anything. So I'm gonna do fast enough to import. I think it's from collections, import leave to deck, and what else do I want? I need a count 0. So let's handle these guys. If element is a 0, then that position is a 0, so that's easy. Say row is this. So and 0. If element is a 1, then you want to run PFS. So say and I believe it's grab the position, then you want to get the current position. And next positions. Let's do. How could I use less comprehension for this? Nodes +1. Let me just keep it simple. Just do +1. So next position equals to current position. Let me not be confused enough. Is current position 0 minus 1. Make sure to not do checks for going out of bounds. Position 1. What's left? Right. Up. Down. Right. Next position. Left. Right. Around here, how to check for the bounds. For the helper. And if 0 is greater than 2,
accidentally refreshed.
Yeah, words. Another indentation error. I don't remember how to multi-line. I'll just leave it like that.
Yes, randomly kicked.
Yeah, that's right. If then bounds left, not then. Left, right, up, down, right. Alright, so let's see. Before this, is that a 0? And we do put 0 if it's a 1. Take that position, pop it. And the next positions, to the left, right, up, and down. Q. Okay, to the pop left. Positions. Actually, would it be next position? Just be Q. Right, it's environment. You can't even do a good copy. Q. You're in our current position. Zero. You want to break. 0. To 1. You want to get out of positions. Bounds. And you go back up again. And then at the end of this for loop, you would say first, here's the pen row. And let me see. So if you're a 0, you just add that in right away. If you're a 1, you want to run DFS. What am I adding into the row? If it's a 1, it's a 1. Oh, so I need to count. When do I start counting? 0.
Okay.
Actually, not even do counts. If you start at 0, then count is already 0. If you start at 1, then you're gonna explore out, and you want to increment the count. This equals to 1. To get to 1, count 1. So you left, you right, you up, you down. Look at the example. So if you're at 1, find the nearest 0. Here we go. Set that. Count this to 0. All right, let me try and do a quick test. See where some issues might be. Let me move this up. So let's see. Then down is 1 required. Of course it is. Position and grid. Yeah. Oh, the chat window's blocking the run button. Let me move that.
Okay.
So target has the object line. All right, so let's see. Oh, because I'm already passing the length for these. So we pass it into the inbounds left is that and that. Its current position is I or J. Okay. So okay, that makes it easier then. So position 0 is greater than 0, or position 0 is 1, position 1 is 0, position 2 by next out of range. Input 2, 3. What are we doing? I'm in position 1 here. Let's see. Is the other you mean?
Okay.
Too Pythonic. Let me. And that looks like there is. Okay. All right, got it. Oh yeah, that makes. Let me see. 0. Yeah, so I would need to mark. Otherwise, I could get stuck in an infinite loop where I keep going up, then down, then left, and right, and up, then yeah. So I will need that visited. Set position. Okay. So if that position is already in there, position visited, continue.
There's the part where the element equals 0, roll that append.
Pardon?
950.
Yeah.
5. I wonder if it needs to be moved.
I'm figuring out if I want to do an if or a not. So if not current position of that, then you want to add it. And so if you get the current position and it's not already in visited, then you add it to visited. If it's in visited, you do nothing. You just continue.
Okay.
All right, so let's see now. So if you're here, okay, pop left. So these to the queue. And then where's position? Oh. That's gone. Let's see. Where's row? Row's right here. Each row. Right there. Fixes that issue. Okay, so that fixes that issue. So now, let's see. Length of grid. Should go through there. Where's row? Where's right here? So count starts at 0. I have 2 counts. What's that? I'm going to start counting. Okay, so let's see. If you do that, every position you move, you want to increment count by 1. So if you start here, get the position, it's not in the visited. What happens if it's in visited? Let me see. So you start 0, that's good. That one should go over by 1. Right now it's going over by 2. Every one you see.
Do you want a small hint?
Should be fine.
Okay.
Left, right, up, down. Current position. start at 0, 0. So it's a 0, 0, 0. That's good. 1, 1's good. Okay. You see the 1, and then it goes to 1, 1, which is down. Then it goes 0, 0, which is 0. Then it goes 0, 2. Okay, so it keeps going. Say. And break out of this earlier. Let's see. Let me think. If I'm at one position, I go to another position. Go up, go left, right, go down. C1. Right here. Down. Wait a minute. You go right here. So see, while your cube has positions, you get the position, you go through directions, it's within, add to Q, and you move to the next one. Add that, add a Q. Did I add the visited? I don't want to add the visited. So would you rather add to the Q? Is it because? I don't think so. Let me get rid of the nearest. I don't think the Q should add to as well.
It's not the way you're adding it, but the way that this count is being implemented.
Okay. That's one. Actually, let me. In case it's not one. So, when do I want to increment the count? If you're here, if you're at a 1, and you go to find the nearest 0, you keep adding 1. Once you found the nearest 0, that's the count. Then you move on to the next position. The count should reset. Where do I move to the next position? I move. Zero. To the right, to the left. So if you get all the, if I get all the positions and then take the minimum, that's what I might have to do. So,
I think. Sorry, I'm just. I think that direction might not be the right direction.
Because I'm thinking if I'm at a 0 or at a 1, and I explore up, down, left, to right to get to the nearest 0, if to the left I get to a nearest 0 within 3 steps, but up I get to a nearest 0 in 2 steps. Well, since it's BFS, it should find the earliest one first. So I shouldn't. Yeah, I shouldn't need to have a list to keep track.
But for the BFS, like imagine you start in the middle, that's 1, and you add 4 nodes, like the up, down, left, and right.
Yeah.
And then those are all a distance of 1.
Yeah.
But this like count plus 1 is being triggered every time you explore one of them. So like the neighbors of the neighbors, like we want to like increment once when it's at the neighbors, like increment twice when it's the neighbors of the neighbors, and like increment when like like all of
Yeah.
these when all of this
Okay. I see
is
what you mean. Yeah.
yeah.
Because if it goes left and increments 10 and goes up, it takes the previous count and keeps adding onto it. Yeah.
Mhm.
Um, hmm. How do I address that? Where's the current position? This one. So the count would be current position minus the current position.
So I guess I feel like the way to do it with a count may not be intuitive.
Yeah.
I think it's okay if we don't get there. Like I've seen, like I know there's like having two queues, or
Yeah.
like having some value indicate like it's the end of the first set of neighbors and it's the start of the second set. Um,
Yeah. I mean, while I was thinking about
yeah,
it, I realized that there's probably some core to the problem that I missed when I jumped into the implementation. So I'm probably not going to finish it in time.
I yeah, I think it's fine. I'd like to just take some time to like uh chat about some thoughts around the problem.
Okay.
Like for instance, like if you were to calculate the time complexity, like um what do you think it would be? But like how are you getting to that?
Would you clarify what you mean by how are you getting into that?
Oh, or I guess like what's the time complexity? And then I'd like to hear how you're calculating the
Okay.
time complexity.
So the within bounds helper function is O of 1 because it's just
Mhm.
checking if the positions are greater than or equal to. And then for the for loop on line 43, so that would be an O of n. Let's assume their rows and the columns are a different number. And
Mhm.
then J would be O of m. And
Mhm.
then the BFS is V plus E, which should just be n. In this case, that's the whole side of the grid. So that would be another n times m. So total will be n squared times m squared.
Okay.
Yeah.
Yeah. Yeah. And then but are you familiar with how like a knight moves in chess?
At one position, it can go two
Mhm.
positions either in one direction and then one position to the other direction. So it's either
Yeah.
up, up,
Yeah.
left, or up, right, down, down, right, and so on, left, left, left. I don't have
Yeah.
a mathematical formula for its positions.
I'm kind of curious like let's say like if it was like number of knight moves to like minimum number of knight moves
Yeah.
to like a zero, like how you would how we might like change this.
We say minimum number of knight moves to zero.
Yeah, instead of like up down left right, we
Yeah.
could transverse like up left, up right, left up.
Okay. I get what you're saying. Um, yeah, I mean, the challenge for sure is that I'm sure you've had this. We all have it in interviews where if you're not used to thinking out loud while you think and write, that trips you up. So I think, of course, that's just something we practice, but especially when it comes to grids,
Mhm.
it's easy to mix up the numbers if you're
Yeah,
thinking
I
out
think
loud.
yeah, I
Yeah.
feel like with interviews, I guess I hate the process of going through interviews.
Yeah. Like it's a necessary evil. The more problems practice you do, the more comfortable you get doing it. But if you're day to day, you're not thinking out loud, then you typically get tripped up over. Like if I go after now and see the solution, I'm thinking, okay, that looks very obvious. If I was in a calmer environment, I probably would have realized. But yeah, the stress always gets to you at some point.
Mm.
Um,
Yeah. Um, I mean, I think you have like really good clarity and like your thinking process. You asked like for clarity. Well, like I think there's like certain signals and getting to like a work. tracking solution is like just one other signal.
Yeah.
So I think that will just go in like my feedback for the hiring manager, and then it'll be up to like the hiring manager. But I feel like yeah, I don't like having to think of problems on the spot as well.
Yeah.
Um, do you have any questions that I might be able to help answer about, or like?
Yeah, no questions at this time.
Okay, cool. Yeah, thank you for your time and have a nice one.
Yeah, likewise, and thanks a lot.
See ya.
Bye.